let's go on and continue to find area of other types of polygons. How about a trapezoid? So with a trapezoid, we have two parallel sides, and those sides are called the bases, and then we have a segment perpendicular to the sides, and that's called the altitude. And remember, the altitude is always going to be drawn to a base. So here's an example of a trapezoid. So AB is a base, and CD is a base, and then we have altitude AC. So the equation for area of a triangle is 1/2 base times height. Well, here, this isn't quite a triangle because we have two bases. We have two bases. So we can remember that the area of a trapezoid formula kind of looks like the area of a triangle, except we have to remember that we have two bases. So the area of a trapezoid formula is 1/2 base times height. We have a height, which is our altitude, but we're going to add both bases together. We have to account for both bases in the area calculation for a trapezoid. So let's look here. Given that RS is parallel to VT, that tells us that RS and VT are our bases. Find the area of the trapezoid. RS is 5, VT is 12, and RW, the altitude, is 6. So our area is 1/2 the height times base 1 plus base 2. So our area is going to be 1/2 times 6 times 5 plus 12. Those are the two bases taken together. So 1/2 and 6, that's going to be 3 times 17. I'm sorry, they said it's 13. TV is 13. So that's 3 times 18. So our area is going to be 54. And what were our units? They didn't give us units. So we're just going to write the word units squared. So for a trapezoid, we take into account that we have to add both bases into the equation. Now there's another formula for area if it happens to be the type of quadrilateral where the diagonals are perpendicular. What kinds of quadrilaterals have perpendicular diagonals? Well, a square, but area equals side squared might be easier than what we're going to propose here. A rhombus has perpendicular diagonals, and a kite also has perpendicular diagonals. So if it happens to be the kind of shape where the diagonals are perpendicular to each other, the area is 1/2 multiplying the two diagonal lengths together. So here we have the category of finding the area of a rhombus. Rhombus is one of those shapes. By definition, the diagonal of the rhombus is perpendicular to the diagonal of the other rhombus. So we can use our formula. We actually do have an example here to find the area of this rhombus. And we're told that MP, which is this diagonal, so one of the diagonals is 12, and we're told that NQ is 16, so the other diagonal is 16. So my area is going to be 1/2 12 times 16. 1/2 of 12 is 6. 6 times 16. So my area is going to be 96. Did they give us units? No, they didn't. So we're just going to use the word units. Units squared. The area of that rhombus would be 96 square units. Now, remember, they may not actually give you the diagonal lengths. You might have to determine the diagonal lengths, but the thing about a rhombus is that the sides are all congruent and the diagonals are perpendicular, making right angles. So you might have to use Pythagorean theorem to find the side of a triangle, which is half of a diagonal. So there might be an extra step, but it's still going to be okay. You still have what you need to calculate area of a rhombus. Now a kite is another shape whose diagonals intersect perpendicular, and also this diagonal bisects the other diagonal. But since the diagonals are perpendicular, we can use our formula that the area is 1/2 diagonal 1 times diagonal 2. So we're going to go through an example of that. Here they want us to find the length of RT. So here they want us to find the length of this diagonal. If the area is 360 square inches and SV is 30. So area equals 1/2 D1 times D2. So they told us our area was 360, 1/2. They told us that one of our diagonals was 30, and we're trying to find the other diagonal. We're trying to find the length of RT. So 360 is going to be 15 times RT. Well, to get 15 by itself, to get RT by itself, I'm going to divide by 15. And what I'm going to find is that RT is going to equal 24. And we're going to go back and see what units. And since this is just the length of a segment, it's just going to be inches, linear units. Now the last property is, what can we know about the areas of similar polygons? So, similar means same shape, but not the same size. The sides are in proportion. The sides are proportional. That's what similar means. So, triangle A1, B1, C1 is similar to A2, B2, C2. And so you know what? Their heights or their altitudes, the proportion of A1 to A2 is the same as the proportion to B1 to B2 is the same. The corresponding sides are all in proportion, and the altitudes are in proportion also. So, since area is a square unit, we have that the area of the first triangle with the ratio to the second triangle. The area of the first triangle to the second triangle is equal to the same ratio of the first side to the second side squared, because area is a square unit. If we don't want to use the A sides, we can use the B sides. If we don't want to use the A or the B sides, we can use the C sides. But the areas are in the same ratio or are proportional to the sides squared. And here's our theorem right here. The ratio of the areas of two similar triangles equals the square of the ratio of the lengths of any two corresponding sides. So we know that the area of triangle 1, the ratio of the area of triangle 1 to the ratio of area of triangle 2. Here they want us to use the ratio A1 to A2 to compare the areas of two squares in which each side of the first square is 3 times as long as each side of the second square. So here's going to be our first square. and here's going to be our second square. Each side of the first square is 3 times as long as the second square. So let's just use numbers to calculate this first. Let's say this square has side length 2. That would mean this square has side length 6. So in this case, the area of triangle 1, area of square 1 would be 36 square units. And the area of square 2 would be 4 square units. What is the ratio 36 to 4? It's equal to 9. The area of this square is 9 times larger than this square because the side of this square is 3 times longer than this square. All right, now let's just find it in general rather than, calculating 36 and 4. Let's say all we know is that this side is 2 and this side is 6. The ratio of the area of 1 to the area of 2 is side 1 to side 2 squared. Side 1 is 6. Side 2 is 2 squared. 6 divided by 2 is 3 squared, which is 9. So just using the ratio, I could have calculated the ratio of the areas without actually finding the areas of each of them individually.